Ah, yes. It's like 1:30 in the morning and I'm a little bit tipsy. I don't care. I'm doing a stress test on this amplifier. Now, this is my 25 watt RMS, which is incorrect. 25 watt average power amplifier, about 50 watt max, that I had to redesign the board, mainly so I could get some mounting screws to actually mount into the heatsink properly, so it could you know, support the board so it wouldn't be like stressing on the solder joints, because I plan to use a heatsink like this, but unfortunately this power amp isn't going to cut it. The measurements between this hole and that hole are so bad that I cannot get it between the fins, so I won't be using it. I've also pinched the variable potentiometer off of it, and currently I can feel the heatsink is getting warm. The transistors, yeah, are getting warm. Now, I'm using two different types of output transistors as compared to the original over here. This is a TIP35C and TIP36C respectively. So I'm using a 2SA1294 as a PMP transistor, which is over here. And I'm using a 2SC3263 here as the NPN transistor. It makes absolutely no difference to the circuit. It's not going to produce any more power using Japanese transistors. It's just transistors I had that I wanted to use. So I tried it in this design and it seems to work okay. I mean, my drivers are getting hot as well. They really need to be mounted to the heatsink. But I've been running this at full power for about 10 minutes, and I'm just doing a stress test on it to make sure that the thing isn't going to fail, as in it's going to go into thermal runaway. We're still producing the same amount of output that it was when I started. I've calculated the values. I'm pushing about 48 watt peak and roughly 26 watt average. So the idea here is that I want to run that amplifier at full power before clipping for as long as possible and see how hot it gets, just so I can see what my thermal runaway is. Now, the DC offset on the output is slightly higher using these output transistors. I'm experiencing close to 200 millivolt as soon as you power it on, but it starts to slowly drop off to below 150 millivolt. So yeah, it's still okay to have that amount of DC offset on the amplifier. I would like it to be lower. It's just the overall design, but I did actually change my feedback resistor to a 33K, so that's going to also affect my DC offset plus my input sensitivity. The original was 1.8 volt peak to peak for full power. Now it's about 1.3 volt peak to peak for full power. Greetings, the Astro 30 here, yet again messing around with this power amplifier module. Now, I don't know if the intro to this video made any sense because I was pretty drunk. Anyhow,
As I was saying, I rebuilt the power amplifier and made the board a little bit larger so that the hole centers for these two mounting holes will fit between the fins of that other heatsink. Now, I've done the stress test on it and this fared pretty well. It remains a stable temperature. It wasn't really overly hot. I could sit there and hold it. I reckon it wouldn't have got any more over 20 degrees. I didn't measure it. But this dummy load, whoa, yeah, even sinking 50 watts into it, it was red hot. That just means that this should really be mounted to a heatsink. That's why it's made of aluminium and has holes in it to screw it to something. I would screw it to a heatsink. It obviously can't dissipate the heat quick enough. Now, the only issue I had when building this was this link wire was sitting up a little bit too high, so when I reheated the joint on one side to push it back down, this pad here started to lift. So I've pushed it back down, but if I was worried about vibration causing that joint to break, I would probably just stick a bit of hot glue on that. Which is a shame, and yes, an expletive did come out my mouth when that happened, but I wasn't going to remake the whole entire board just because of one little minor error in my own judgment. As I say, a little bit of hot glue on top of that solder pad there to the board will stop it from vibrating and breaking, but I have actually pulled and pushed on the link on the other side and it's not breaking or anything or moving. So I did notice there was a bit of crap stuck here. Go away. So I suppose I should really hook it up to a speaker just to test that. I am a little bit annoyed that DC offset's increased slightly. I was really trying for a DC offset of no more than 60 millivolts on this thing, but it's not going to happen. But I did prove one thing, that really, as long as the output stage transistors that you use are well within the capabilities of handling the supply voltage and the current that's going to be dissipated through them, you can use any type of output transistor you want, as long as the pinouts are the same, of course, and they're the same physical size. But yeah, these Japanese transistors are working just fine in here. I don't see any issues with using them. I just had a set of 4 each, so I've got the 2SA and the 2SCs in 4s, so I just wanted to use them. Okay, I've got the power amplifier hooked up to the crap speaker on the floor, and I've got the power supply next to it set to around about, well, the full capability of the supply, which is around about plus minus 30. So I'm going to turn the load on. There's that annoying thump. But it works. And I can hear a slight hiss coming out the speaker, so it's not that bad, but that's basically the DC offset. So now, to get rid of that annoying thump, I'm going to incorporate this speaker protector module I built the other day and see if that's going to, well, work with that board fine, but also eliminate that thump. Okay, it's hooked up. The supply is just going across the DC positive and 0 of the amplifier here. Output goes into the input of the protector, and the output of the protector just goes into the speaker driver. So if I turn the load on now, there is no thump. And if I turn it off, there's a slight little pop there through the speaker because, well, this is not going into a power supply that has filter caps that hold a charge behind it. If there was like a filter bank of, 4700 microfarad capacitors, as you normally would find, that would take a while for it to discharge before the amplifier finally cut out. But because it's connected to the DC supply with no filtration, as it normally would be, there's going to be a slight thump or pop when you turn it off as the power supply rails collapse. And there was a slight little click through the speaker when I first applied the power, for whatever reason. But yeah, no, that speaker protector is working with it. I'm happy. Okay, so now I've got the amplifier hooked up across a 50k linear pot as a volume control at the input, connected to the CD player. Now it's going to pick up a bit of a buzz now because of the wiring, plus it's all close to the power supply, so it's going to pick up the hum from the transformer. I don't know if you can hear that buzz, but yeah. Anyway, that's why that's there. So hopefully I don't get hit for copyright, so here we go. Just a little bit of directions in groove. Yeah, that's the first music signal that this amplifier has ever amplified, and even into a 15 ohm speaker load it's remaining perfectly stable. So it's not thermally running away or anything, and it's been running for the last 6 odd minutes. I've cut the song down during editing, obviously, because it's just way too long. But no, it's proving to work okay. That issue with the link wire between, which is actually only going between the base of this transistor and the emitter of the driver, so it's just the link, because I forgot to mention that I've also increased the route sizes. So my original traces were about 40mm, that's MIL, not millimeters. I increased them to 50 in some areas, 60 in others, and 70, etc. And I also removed the routes at the back of the board between the transistors and used links instead, so I could bring the circuit board closer to the heatsink, or the transistors closer to the heatsink, without having to bend them. So that was the whole entire point of those extra link wires. It's annoying with single-sided circuit board, but that's just what it is. So it's working. So the next step would be to actually mount this on its proper heatsink, drill out all the holes and tap them, and plus add the PCB right-angled mounts to either end of the board there to give the board some sort of structural rigidity against the heatsink, so it's not going to flex on the solder joints. And yeah, go from there. Now the astute viewer may have the inkling that now I've got a speaker protector connected to the power amp here, that all I need to do now is add that 4-channel mixer preamplifier ahead of the power amplifier, and I've got a complete amplifier. Well, guess what? Your inkling is right. That's exactly what I'm going to be doing. I'm going to be putting that preamp ahead of this power amp, mounting it all in a case, and building yet another amplifier. Why not? I can. Don't exactly have the time left in this house to do it, so I don't know when I'll ever get around to finishing it, but I can start it at least. But I need to get hold of a rack case from Ultronics first and a 25025 toroidal transformer in order to power it, and then we can do a final power measurement on this and see what it actually outputs at that full voltage. But yeah, no, that's working fine. It's not overheating, it's not even getting hot. I'm happy. So yeah, the next step is to mount this onto a heatsink, a proper heatsink. These are always a pain in the ass to drill and tap. And about an hour later, I've got the heatsink drilled, tapped, and the board mounted and all isolated. I've got a 470 ohm 5-watt resistor across this fuse holder, fuse removed, meter across the resistor. So I'm going to turn the load on and I'm going to check what the quiescent current is. I should have about 11.5 millivolt, 11.5 volt on the meter. Now remember, on the higher voltage power supply, I'm going to have to end up turning it back down. So here we go. Well, we've got about 12 volt, which is a little bit high, so I'll bring him back closer. See, the thing is, as that transistor heats up, it's not going to stay there. It'll keep increasing or decreasing with heat as it's supposed to do. So currently we're at 11.6. I'm probably going to say that's okay and leave it around about 11.2. Okay, with the fuse now installed, I've connected the meter across the output and ground, and we're going to look at the DC offset on the meter here. It's currently at 285 millivolt, but that's with it turned off. Turn it on, and we're more like 180 odd millivolt, and as we can see, it slowly drops back off. I don't think I'm going to be able to get that DC offset any smaller. Well, I probably could have if I used the current mirror in the long tail pair. It probably would have reduced the overall DC offset a lot. But anywhere up to 200 millivolts is still fine. Where'd that go? Oh. Okay, I've got the oscilloscope hooked up across the dummy load and the DDS connected to the input. Oh. Yeah, right. Yeah, we've still got an output and we're still pushing around about 39 volt peak to peak. All well and good. So I thought it would be fitting to end this video by testing this power amplifier module with the preamplifier module connected to it that's going to actually be, well, joined to it in the final product. Got my little 15 volt plus minus regulator breadboard over there. Speaker protector over there in the background, power amp, input module and preamplifier module, or tone stage, whatever you want to call it. So, relay works. So I've got it hooked up to my base. The only thing is, this transistor does get quite hot when running on DC, so I've got to keep that in mind and not run it for too long. Here we go.
supposed to be Directions in Groove, the favourite, but anyway. Anyway, that's enough of that. You get the point. Anyway, thanks for watching, and I'm going to end this video here. And if you enjoyed it, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya.